main shock at the northeast end. Then that was followed by a magnitude 5.4 aftershock at 4:07 yesterday morning. And then in the evening on Friday, things picked up rather quickly with a magnitude 5 foreshock at 8:16 p.m. and then a magnitude 7.1 main shock at 8:19 p.m. So when that 7.1 occurred, we called that the main shock because it's the biggest event so far in the sequence, and we call the previous events all foreshocks to that main shock. Now, that main shock ruptured the fault, as you can see, from the bottom of the picture down there on your right, from the Gallock fault, if you like, all the way up towards the coastal geothermal field, which is a distance of about 30 miles. And so if you look at the epicenter of magnitude 6.4, then it was rupturing, the 7.1 ruptured 10 miles to the south of that and 20 miles to the north. And it had a depth of about 8 to 10 miles. So since then, we've had 6 magnitude 5 or greater aftershocks, none greater than 6, but one greater than magnitude 5.5 at 8:47 last night. So far, we have a complete picture of the magnitude 3 and larger, and so far we've processed data from about 2,600 aftershocks, of which 52 events are greater than magnitude 4. And we have about 340 events of magnitude greater than 3. So if you think about how there is many more small earthquakes than big ones, then our goal is to have a complete catalog of earthquakes down to a magnitude 1. So that's 2 orders of magnitude smaller than what we have, smaller magnitude than what we have now. So we expect that this sequence will generate over 30,000 earthquakes of magnitude 1 and greater. So to actually harness that information out of our data streams, we are now loading the data onto Caltech supercomputers and plan to use AI and machine learning codes to get that information out of our data streams. So the USCS has calculated probabilities for a magnitude 7 in the next week. It's now down to 3%. It was 6% yesterday. And the probability of magnitude 6 is 27%. So we're likely to see maybe 1 or 2 of those in the next week. So those are the main points that we wanted to raise today. Are there any?
How strong was the earthquake felt here in Los Angeles?
It was, so the earthquake was a magnitude 7.1, and that describes the size of the earthquake itself. Now, the way we describe how things are felt in LA is with what's called shake map, which is the color map on here. And unfortunately, this color scale is not showing, but the shaking in LA was somewhere between modified Mercalli 2 to 3, mostly. In occasional places, it may have gone up to 4. So that means people felt it, but things were not being knocked off shelves.
Can you elaborate a little bit more, Doctor, on the science of foreshocks and main shocks and how that works? What triggers one or the other?
So foreshock, main shock, and aftershocks is nomenclature that we use to identify the events. So the biggest event in any given sequence is referred to as the main shock. Anything before that event is referred to as a foreshock. Anything after the main shock is referred to as aftershocks. If we have a big event, like in this case a 6.4, followed by 7.1, for a while the 6.4 is the main shock, but then we transfer the name of main shock onto the bigger event that occurs later.
fault line that you guys were watching? Were you expecting a large earthquake here eventually?
Well, we're expecting large earthquakes on all the faults in Southern California. In particular, this area is quite active and has been active since we've had good records since the 1930s. And particularly since the 1980s, there's been quite a few events, and in the 1990s. And for a while, Ridgecrest was known as the earthquake capital of the world because they had so many small earthquakes. And so it's not a big surprise that this sequence happened.
Is there a network of faults along one main fault there, or is it like a swarm?
It's kind of a broad area, about 10, 15 miles across, where there's a network of faults, and that's why we refer to it as the Little Lake Fault Zone, with emphasis on zone. It's quite wide. So the deformation is not concentrated along one strand, like, for instance, along the San Andreas, where most of the deformation is on the main fault itself, where the width of it is maybe a few tens of meters, as opposed to here, you're talking about 10, 15 miles.
For people in LA County who have been nervous by the shaking we're feeling from this Searles Valley sequence, is there any incidents where, even in a bigger quake or in a quake that was triggered by the Searles Valley sequence, any scenario in which there could be damage in the LA area from a quake of that sort?
Could you repeat that question?
Sure. We're feeling these earthquakes from this sequence in Searles Valley. Is there any scenario in which earthquakes that far away could cause damage here in LA County with the way in which we're feeling them?
It's very unlikely. We haven't seen any damage from these earthquakes, but earthquakes at this distance can cause some damage in very isolated cases, especially if the ground is very soft and saturated with water. It can induce liquefaction at a great distance, but in this case, it hasn't happened.
How big would an earthquake need to be for it happening for us to have any damage here?
It probably would have to be more like, say, the 7.8 on the San Andreas Fault. But in some respects, these earthquakes, we are lucky in that the energy in them is mostly going to the north, away from Los Angeles. If they were rupturing from north to south, then there would be more likelihood to have damage in, say, Palmdale or other areas that are a bit closer than, say, downtown LA to this activity.
Do you have seismologists out there at the epicenter, and what are they seeing? Is there scars on the earth?
Yeah, there are both seismologists and geologists looking for the scarp from the first 6.4 as well as the 7.1, and they are seeing very clear scarps in the ground. Most of those features are within the China Lake Naval Weapons Center. So access is somewhat limited, but they are able to fly helicopters to take video and collect important scientific data.
Yesterday on that map that's slightly covered, it looked like a pretty solid L, and now there's a lot of spread out dots, blue dots. Is that the 10 to 15 miles that you're talking about across?
Maybe Rob Clayton could point for me, or Rob Graves, is he there? So let me.
He's coming. He's coming.
Okay. So let me explain that again.
The map that's
Yeah. So if you see the map in the upper right-hand corner, it's now like a T. So on the leg that's pointing towards me, that's the one that. So point at the epicenter of the 6.4. There, yeah. So it ruptured to the southwest towards Ridgecrest, and that's about 10 or 12 miles long. And then the 7.1 was located a little bit further north, like there, and it ruptured bilaterally in two directions, both to the southeast as well as to the northwest.
Sir, correct me if I'm wrong, so these earthquakes are coming to surface?
Yeah.
The 7.1 was shallow compared to the 6.4?
I don't think we can tell yet, but they're all probably at a very similar depth. in that they go down to about 8 miles and then they rupture up to the surface.
So can you explain when it ruptures up to the surface, what does that do, and how does that come, what does that speak to when we talk about damage and how we are feeling it?
So what it means that the earthquake is a movement on a fault, which is a zone of weakness in the ground. And one side translates relative to the other. And in this case, we don't know exactly how much it moved. That's why we have geologists out there measuring it. Could be anywhere from a few inches to maybe a few feet. And the damage would mostly be if you have a structure, bridge, or a building built across the fault, then that could be, the earthquakes could cut it in half or severely deform it. So that's one issue. Most damage from earthquakes is actually from ground shaking, not from fault offsets. But there are regulations in the state that for major earthquake faults, you're not allowed to build a building across the fault because it's not a good idea.
Are we still looking at 2 faults then? And do we know what faults those are?
We're looking at 2 fault strands within a fault zone. So this is a broad zone of many, many faults, and there are 2 strands within the Little Lake fault zone that are active. One pointing towards me to the southeast or towards Ridgecrest, and the other one is the northwest trend that you see on there in that T. And so that's still part of the same deformation zone.
But they don't have specific names on those 2 faults?
Not yet, no.
Can we talk about probability again? Yesterday, Dr. Jones had said there was a 1 in 20 chance that we could see an earthquake bigger than the 7.1
Yeah.
following last night's
Yeah.
earthquake. As in any earthquake, she said. What is that probability now?
It's 3%. Instead of yesterday, it was 5%. Now it's down to 3%.
Okay, and what about for a 7, a 6?
No, so 7 and greater is 3%. 6 and greater is 27%. So we are really likely to see a 6-ish size event in the next few days or the next week.
What was the projected number of aftershocks again, over what period of time will these occur?
So most of the earthquakes, aftershocks, occur in the first few days after the main shock. And so far, we have recorded about 340 events of magnitude 3 and greater, and we feel like that is a fairly complete record. So if you include all the 2s and 1s, that will be about 34,000 aftershocks for this sequence.
34,000?
Yeah.
In what period of time?
That would be over the first, say, 6 months or so.
Can you talk at all about the Shake Alert LA app? I know since it's originally happened on Thursday, they have now, I guess, or plan to now lessen the intensity restrictions.
I could say a few things about that, but Shake Alert itself is a project run by the U.S. Geological Survey, and the university partners like Caltech, UC Berkeley, and others are participating in developing that system. That system functioned as designed and issued an alert 8 seconds after the main shock, magnitude 7.1, and kept issuing alerts, so people who were using our development tools were able to get warnings. Shake Alert LA is an app that's developed by City of LA. It listens for messages from the Shake Alert system. Sorry about the confusion of the naming, but that app is set for fairly high thresholds and mostly to warn on earthquakes in LA County. And currently the USGS committees that govern the sort of release of messages and so forth are meeting, and we've put in a strong plug to them to actually lower the thresholds, because there is some misunderstanding in that the USGS thinks they should only warn on damaging shaking, but it's clear that people want warnings even though the shaking is not damaging.
When we talk about an earthquake of this magnitude happening closer to Los Angeles, how well prepared are we with our structural integrity and our response times from your perspective to deal with something like this, if this were to happen closer
I think in some ways we've done a lot. It's clear that the city of LA, with various retrofitting ordinances, has stepped forward and is spearheading, leading other cities to improve the infrastructure, but a lot remains to be done. What we're seeing out in Ridgecrest and adjacent small cities is, for instance, gas pipelines are breaking, things are catching on fire, roads are being damaged, and we haven't heard much about water, but power has been out. So those are all big concerns, and I think, yeah, we need to learn lessons from this earthquake and apply them so we're better prepared when there's a major earthquake. And if there was a major earthquake in the LA area or on the San Andreas, probably most of you would not have been able to make it to Caltech, because sufficient amount of bridges, freeway bridges and so forth, would have collapsed and you would not be able to travel easily through the city.
So the structural integrity of a lot of our overpasses and bridges are not up to par when it comes to earthquake code?
I cannot speculate on specific bridges, but it is a concern that, yeah, they may not fall down, but there may be sufficient shift in things that, so they may not be passable. Even though Caltrans has done a lot to strengthen them, still earthquakes somehow seem to be always stronger than we thought they were.
And just directly after those two major incidents, the 6.4 and the 7.1, we had some water main breaks. It's not clear if they were actually tied to the shaking, but I know a lot of folks are concerned about, you know, even that system underneath our city, the integrity of that system.
Yeah, so from the studies that have been done, looking at the effect of earthquakes on the infrastructure, power is not a big issue because we can always borrow a generator. The water is an extremely big issue because a lot of our pipes are very old and need to be retrofitted to be seismically more resilient to be able to provide us with the water that we need. And if we don't have water, I think we're all going to go someplace else. But
could fracking in Kern County have anything to do with these earthquakes?
I think that's no. I think I can answer that no. I don't have to put a qualifier on that. There is a geothermal area at the very north end. I don't think Rob can point that out. That's the coastal geothermal area, where there's a very large energy production going on, where they pump water into the ground to harness heat from the rock. But if they had had something to do with this, we would have expected the activity maybe to start much closer to the geothermal area and then emanate from there. But again, the reason we have a geothermal field there is in part due to the active tectonics. It's due to the ongoing geological deformation. So in that particular area, the crust is being thinned and pulled apart, so heat can easily rise from the interior of the Earth, and we are able to harness that for electricity production.
Last question? Thank you.
Yep, you're welcome. Thank you.
Can you say your name one more time?
Eyal Hoxton.
Eyal.
Yeah.
It's spelled
E as in Edward, G as in George, ILL, HAUKSSON.
the title is patient.
Huh?
The title is
Doctor? Yeah.
they want to do a rap.
Is there another planned update today?
I don't think so. We unless there's new development, we don't have a lot more to say. So, yeah.
I wondered if you could describe for me briefly, if it's at all possible, briefly describe the actual motion of the fall, like what was actually happening. Does it go this way?
It goes horizontally, so this maybe is one side, and that's the other side. So this one is going this way.
Everybody's fine.
If you're standing over here, then this side is going this way.
So you're gonna see kind of a you would see kind of a vertical shift.
No, horizontal shift, but because sometimes there are bumps, so let's say these two bumps are here, so you move this one there, then there's an apparent vertical shift over here. You see that?
Right.
If it's flat over here, there's a bump, you move it over there and you go from here to there, there's an apparent vertical shift.
Can I do a quick video of what you just showed me?
Sure. I don't know.
Sorry. Okay. This is Dr. Daniel describing the shift of the plates.
So the fault shifts horizontally, but if there's a small topographic